Hi everybody, Dr. Daryl Boston's here with Barrie Chiropractic and Health Services Center, and we're continuing our series of Ask the Doctor videos, hoping to enlighten people with frequently asked questions that we've gotten over the years. And by the way, we'd invite you, if you have a question that you'd like us to address, to fill it out and put it in our suggestion box or let our front staff know. So today I want to talk about joint pain. Figures, chiropractor, want to talk about joint pain, but specifically I want to talk about joint pain and how it pertains to weather. So how many people can tell that the weather's going to change because different parts of their body hurt? So I get that a lot. So I want to explain why that is. Most people associate joint pain with weather changes because of the dampness. Well, I can tell it's going to rain because my knees are hurting or I'm getting a headache. Those are probably the two most common weather-related joint problems that I have seen in my career. So I want to talk about that. This started out as a bit of a theory that I don't know if I had it myself or if I heard about it. I probably heard about it somewhere. So I actually took a course on meteorology to try to understand a little bit better barometric pressure and humidity. So between my chiropractic and physiology knowledge and a little bit of meteorology knowledge, this is the explanation for why weather changes and damp weather tend to cause joint pain. Here we go. So in a previous video, I explained to people that joints, there's different kinds of joints, but a good portion of the joints in our body are encapsulated. So the knee joint is a really good example. So you've got the shin bone, which comes up to a plateau, looks a little bit like my fist, and you've got the thigh bone, which comes down, and it also has a plateau that looks a little bit like my fist, and they come together on a big area so it can bear a fair amount of weight. Well, around that entire joint is a ligament. So ligaments are tissues that connect bones to bones. Tendons are tissues that connect muscle to bone, and maybe we'll talk about that in another video. But that ligament creates a fairly densely woven capsule around the entire joint. And that's important because it keeps the bones from falling apart, for one thing, but it also allows the inside of the joint to be closed off, because inside a lot of these types of joints there is fluid and there's cartilage. There's cartilage on the ends of the bone which act as a shock absorber, and it acts as a lack of friction so you don't get a lot of heat buildup. But there's fluid in there which also help to reduce heat and reduce friction. And it really is an amazing thing because there's I don't remember what the coefficient of friction is inside of a joint, but it's really, really small. There's almost no friction at all, which is pretty amazing. So the take-home point here is that there's fluid inside the joint, and that joint is encapsulated by a ligament, which means that we have a closed vessel. And if you remember from, I think it was grade 8 physics, maybe a little bit in high school, a closed vessel with fluid inside of it is subject to the gas laws. I don't remember all the gas laws. There's Wolff's Law, there's so-and-so's law, blah, 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 blah. I actually do some scuba diving, so I had to learn a little bit more about how when you go underwater and the pressure of the water increases, it tends to compress gases, which would increase the pressure, right? And as you ascend, the pressure in the water lets go a little bit. So that means that the pressure would decrease, so fluid would then expand, okay? So maybe a better example is a pop bottle. And this will probably be the only time that you ever see a soft drink in the office. Okay, so if you look carefully at this bottle of pop, it looks pretty smooth inside there. If I try to compress, we know that this bottle is made of plastic, and I cannot compress that because of the pressure that's inside of it. So when they package this Coca-Cola, they force carbon dioxide into it, which makes it kind of fizzy, right? And then they put it in this vessel and they cap it off, so the vessel is now closed. Fair enough. So inside that vessel, there's a fair amount of pressure because the carbon dioxide has tried to escape the pop, and it has then equalized. Now we know that if I open this cap, I'm going to let the pressure out inside here. So the pressure in the atmosphere is less than the pressure inside the pop bottle. So if I let the pressure out, then the extra pressure inside the bottle is going to escape into the atmosphere, and the inside of the vessel will equalize with the pressure in the atmosphere. Fair enough. Well, when you listen to a weather report, oftentimes they'll tell us what the pressure is doing. They'll say there was a high pressure region or a low pressure region, and that's because that the Earth's atmosphere has a pressure, and it's usually measured in kilopascals, but we can also measure it in pounds per square inch. But for weather reasons, it's usually in kPa or kilopascals. 101.7, I think, is normal. I think 14.7 pounds per square inch is normal, depending on what part of the world you're in. Well, it changes depending on what's happening with the weather. So when the weather forecasters are talking about a low pressure region coming in, that usually is associated with clouds. So think of it this way. If the pressure in the atmosphere is really high, so it's high pressure, it tends to push clouds out of the way, and it's really sunny and shiny, and everybody loves that. But when the pressure in our area starts to drop, it allows clouds to kind of fill in the low pressure area. And with the clouds brings rain and precipitation. So that's what's happening in the atmosphere. So if this pop bottle was my knee joint, okay, and what we expect to happen is that the inside of our joints will equalize pressure with the pressure around us, okay? So for this demonstration purposes, we're going to say that at one time the pressure inside the pop bottle was equal to the pressure in the atmosphere, which would be normal for physiology. But as we start to get a low pressure region, right? So the pressure's gotten lower, so there's more pressure inside this joint or inside this bottle. A healthy joint, through its movement, acts kind of like a sump pump in a way, so it lets pressure out. So you let that pop bottle, I open up that pop bottle, and all that gas comes out, and you start to see it fizz and whatnot, and now the pressure inside the bottle is equal to the outside. In joints that aren't healthy, if the joint's not moving well, it can't articulate and it can't go through the processes that it needs to equalize the pressure inside the joint to the outside air. What happens is that we get a buildup of pressure inside the joint, just like my pop bottle, and it presses on the joints and it creates a swelling. So anything that happens in the body that does this, takes up more space, that's what swelling is, folks. And that's exactly what's happening. Of course, it stretches the ligament. It creates a lot of pressure inside the joint. It crowds the articulating surface of the joint, and it gets in the way of things being able to move. It causes muscle spasms. It probably chokes off some of the micro blood vessels, which affect circulation, and that's what starts to lead us to the types of pain and discomfort that we might experience. That's why you get joint pain when it gets damp out. It's not because of dampness. It's because of the barometric pressure changes. And it shouldn't happen if the joint was healthy. So unfortunately for people that get headaches, the upper part of the neck has some specialized joints, and the capsules of the joints up there are pretty big. I'm going to show this to you, actually. This is the top of the second vertebra. So you see that joint capsule there is pretty large. I don't know if you can see this, but if you look at this one, down a little bit, it's quite small. So it's half the size of the one in the upper part of the neck. So there's a lot more fluid up there, which means there's a lot more substance to be influenced by these pressure changes. And so if the pressure drops, especially if it drops quick, if the weather changes kind of gradually over a few days, it gives our body a chance to be able to equalize. But when the pressure goes from really nice to not very nice, it doesn't give the body a whole lot of chance to catch up, and that's where people can have trouble. If you have a week where it's going nice, not nice, nice, not nice, not nice, now that will give people trouble too, as will 3 or 4 days of sustained low pressure. Even I tend to get a little bit of headaches after day 3 or day 4 of kind of crappy, dull, damp, foggy weather because the pressure is just so low and there's so much going on inside of us. Healthy joints won't do that. So if you're somebody that's suffering, or if you know somebody that's suffering from joint problems, particularly headaches, especially when there's joint changes, there's a pretty good chance that they have subluxation or joint dysfunction in the upper part of their neck. And that's something that certainly can be helped. I hope that helps explain a few things. One thing that I don't know the answer to is humidity. I know that humidity tends to affect us, especially in the summertime, and I can't figure out for the life of me why that is. Maybe I got to take another course to figure that one out. Until next time, thanks for listening. Know that we very much appreciate you being part of our practice. Bye for now.